This is a demonstration of a tool that's inside of a NeuroGuide software called the LORETA Time Domain Capture. NeuroGuide software is EEG software that is used to do both conventional EEG for visual examination of abnormal events in the EEG recording, as well as quantitative EEG. NeuroGuide imports EEG from 45 different amplifiers by simply clicking File Open and then selecting the manufacturer, the amplifier that generated the EEG that one's going to analyze, as well as universal formats such as EDF and text file and other types of instruments to validate and evaluate power spectra and coherence and other features. In this case, we've imported EEG from a patient who was struck in the right parietal region by a bat. This has resulted in spatial neglect to the left side of the visual world, and also where the patient does not shave the left side of his face, and also has paralysis and weakness on the left side. The first thing when data comes in of any type is to visually examine the record. We have other YouTubes that go through the process of examination and elimination of artifact, and one can page up and page down and know where the unusual events are and gross pathological events such as epileptic events or gross dysregulation such as a theta burst over here. And I'm going to go home, and we can see here that there is a high asymmetry in which the right parietal lobe has much larger amplitude theta rhythm than the left parietal lobe. The right central lead at C4 is also much larger than the homologous left central lead. This is consistent with the patient's symptoms and also with what we know based on CT scan and the clinical record where the patient was struck. But the question we have now is where inside the brain in 3 dimensions, which aspects of the brain are producing this unusual asymmetrical event in the right side of this patient's brain. And this event is a large amplitude theta rhythm. And there's other examples in the record, but what we're going to do is just look at this one. In order to evaluate where inside the brain this event comes, we're going to use the LORETA Time Domain Capture tool, and we're going to expand the time base. Right now, this entire screen is 6 seconds of time. Each blue line is 1 second, and then there's 6 of them. We're going to go to 3 seconds so we get a little better view of the expanded time domain. This is 1 second, 2 seconds. The entire record is 3 seconds, and we're interested in this event. Where in the brain did this event come from? In order to determine that, we click View, LORETA Time Domain Capture, and then we depress our left mouse button and drag it over the event that we're interested in. In this case, the first negative peak, because positive is down, is at 25, is time point 25, right around time point 25, 26. And then the positive peak is at 38. So keep in mind 25, 26, and 38. And now right mouse click, and I can launch the LORETA viewer, which is a 3-dimensional imaging, neural imaging method. I can use linked ears or average reference as the reference, raw scores as z-scores, or the different frequencies. We could identify just the theta rhythm. In this case, for purposes of the demonstration, we'll be using all of the frequencies, and we always recommend z-scores because this is a mathematical equivalent to what's called S-LORETA, standardized LORETA. So I'm now going to launch the LORETA viewer, and I'm going to go to time point 25, and we know right around time point 25 and 26 is the maximum z-scores. In this case, that's 6.8 standard deviations in the right insula, which is a region that has been affected by the injury. And so we can scan around and see that it's in the right temporal lobe and right insula. This is also the right frontal region. The other time point was time point 38, which is the positive peak of the event of interest. And again, we see that that is in the superior temporal gyrus, Brodmann area 29 and Brodmann area 13 for the insula, Brodmann area 41 and 42 are the regions that are generating the unusual activity that we see at the scalp surface in this patient, and also is linked to the patient's symptoms. We also can look at a 3-dimensional display We can adjust the scale so we get a little better color representation by moving this wiper to the right, and then I'm going to fix the maximum so we can play a movie. But you can see the brain here in this region is z-scores that are significantly deviant from normal. They're over 4 or 5 standard deviations. We can play a movie if we wish that will start at time point 1 and then step through each of the time points. I'm going to slow it down by typing 400 in there. That's a delay between each slice, just to make the movie a little easier to see. And at this point, we're running a movie at time point by time point, and eventually we're going to get up to time point 25, and there's time point 25 in that region of the peak we're talking about, in which it lit up over here because of the strength of the z-scores. Now here's time point 36 and 34. And so this is a very useful tool to identify unusual events in the record that one sees by eye, and also very useful for epileptic events. One can look at tangential and radial dipoles, and then with a movie one can see how the epileptic event moves from one location of the brain to another location. And so this is an example of LORETA time domain capture, just one of many tools inside of NeuroGuide. One can then clear selections and then go back to, by clicking View, Edit Data, go back to the standard mouse features of NeuroGuide to do other things such as event marking, amplitude marking, and editing.